use the same data that we had in the previous exercise, which is this table right here from the last exercise. The exercise says, assume C is decision attribute in the system S from the last exercise. Assume that G is stable and A and F are flexible. And it says find action rules reclassifying objects from class C2 to class C1. So we want to find all the action rules. So to find the action rules, we can use pairs of classification rules that we discovered in this problem. We're going to use here the certain rules only to produce action rules with higher confidence. The certain rules were the ones that have 100% confidence. So what we will do is look for pairs of rules that have C2, the class that we want to move from, and then another rule that has C1, the class that we want to move to. We want to change our objects from C2 to C1, so we're going to look for a pair of two rules, one that has C2 and one that has C1. So let's see, do we have such rules here? We have one that has C2. A2 implies C2. We have one that has C1. A1 and G2 implies C1. Now A is a flexible attribute, which is good. So I'm going to mark A and F in blue color just to show that they're flexible. Before we begin our action rules extraction, we need to specify which attributes are stable, which are flexible. So A and F are flexible. show that in blue color. C is the decision attribute. I will show that in red color. And the G is the stable attribute. So the first thing we look for is whether we have C2 on the right side and C1 on the left side. And the next thing we look at is whether the two rules have a common flexible attribute. So we're looking for pairs of rules. Finally, have common flexible attributes. So we can use this pair. A2 implies C2, A1 and F2 implies C1. From the pair of these two rules, we can compose the action rule which says if we want to change from C2 to C1, then A has to be changed from 2 to 1. How about F? F needs to be equal to 2. That's what the rule is saying. But F is a stable attribute. So if it's not equal to 2, it's possible to change it. So what we're going to say is that oh, I'm sorry. I got here I'm supposed to be using here the certain rules. So I'm going to use this rule instead of that one because that is a possible rule. So I want to use the rules with the 100% confidence just to produce higher confidence action rules. So A1 and G2 implies C1. Now, A has to change from 2 to 1 in order to have C change from 2 to 1. This is our action rule. A change from 2 to 1 will imply that the class will change from 2 to 1. Now, how about G? The rule says G is equal to 2. And G is a stable attribute. We can't change it, which means that we have to say here that G is equal to 2. first action rule that we composed, A change from 2 to 1, and G is equal to 2, we'll change C class from 2 to 1. G is equal to 2 means that this rule can only be applied to the objects which have G2. This rule only applies to X3 and X5. The rest of the objects we can't do anything about. Next pairs of certain rules that have, first one has C2, the next one has C1, and there is a common flexible attribute. Can we use A2 implies C2 with this rule? With this one? No, because it has no common attribute. This one has F and G, this one only has A, so it's not gonna work. This one has a common attribute. F1 implies C2, F2 and G1 implies C1. We could use that pair. F1 implies C2 and F2 and G1 implies C1. So the action rule will be what? We want to change from class C2 to C1, so F has to change from 1 to 2. So it will be change F from 1 to 2, and G is a stable attribute, so G has to be equal to 1. We can't change that. Will imply that the class attribute will change from 2 to 1. This rule, G3, with any of these? We cannot, because the G3, the G is gonna have to change from 3 to either 2 or 1, and then we can't do this because the G is stable. Now, if the G was not stable, if the G was flexible, then over here, instead of saying G equal to 2, we will say G change from anything to 2. That makes a big difference because if G is flexible, we can now apply the rule to all these objects, x1, x2, x3, x4, x5, x6, to all of them. Because G, even if it's not 2, we can change it to 2. Even if it's 3 or 1 or x or z, we can change it to 2. So we're going to write from anything to 2. If G is flexible. If it was not flexible, G is equal to 2 only applies to 2 objects, x3 and x5. So our rule has less number of applications in the data set. number of objects that we can apply the rule to. So if you get a rule that this attribute is actually flexible, this is what we need to write. From anything to the value that the rule indicates. So in this case, from anything to 2. This is all for that example.